Okay, I'm back with student page A, fraction estimation. Most of the page is very self-explanatory. Students are going to quickly be able to mark whether these fractions are greater than or less than 1/2. Now, some of them are benchmark fractions. Students probably already know that 2/3 is greater than 1/2. If they don't, we can use pictures to show them. We can give them circle and divide it in half, divide it in thirds, color them in, let them see that 2/3 is indeed greater than 1/2. There are lots of online tutorials that will show them that as well, and it will be a little bit better because it won't be hand drawn. 1/4 smaller than 1/2. The students know that because it's a benchmark fraction. If they don't know that, of course we can go towards making common denominators and comparing those fractions. However, again, these exercises are more about thinking about what we know about fractions and not necessarily using those tedious strategies of always making a common denominator or always turning it into a decimal, because we want students to know that they can think about fractions just in their head and get some of the answers without having to go through all those steps all the time. So when you get to other ones like 9/12, this is not a benchmark fraction. Students don't have a really great picture in their head of what 9/12 looks like, but they do know what 1/2 looks like. So when we talk about this one, we're going to ask students, what do you know about 12ths that is equal to 1/2? How many 12ths would you have to have a half of something? Well, most students, after they think for a second, are going to be able to tell you that 6/12ths would be half of the candy bar or half of the pizza. And as soon as they do that, they can compare 6/12ths to 9/12ths. And now they know that 9/12ths must be bigger than 1/2. You can use that same strategy through this whole paper. 4/6. If they don't already know that 4/6 is greater than 1/2, ask them what half would look like if it were in sixths. Students are going to tell you 3/6 is half. Well, we're talking about 4/6, which means we're a little bit, just a tiny bit bigger this time than 1/2. That's the top half of the paper. It's pretty self-explanatory. Again, I wouldn't give students this paper and let them run through it real fast. I would project it up on the board or use an Elmo and go through individual ones with modeling. Let students try a few on their own, a few with you, and then work through it that way. The bottom of the paper ramps things up a little bit. Students are asked to complete these fractions, making them all close to 2/3, but just a little bit bigger. Okay, so that takes a little bit of thought. The first fraction I would work with is the 12ths. This is the only one that students can really match it up to 2/3 in a mathematical way that they're used to. If they wanted to set this up to find out what 2/3 looks like if you write it as 12ths, they can do that with this one. We can see that this 3 was multiplied by 4 to get 12, right? That means they have to multiply by 4 on the top. So 8/12 is equal to 2/3, but the paper doesn't want equal to 2/3. It wants a little bit bigger. So what's the next number after 8? They're going to say 9/12 is a little bit bigger than 2/3. You can use that same process, however, it's not as easy with 10 and 11 because there's not an easy way to go from 3 to 10. And there's not an easy way to go from 3 to 11. So you might end up confusing students. What I would resort to is I would start talking about half again. I would say if we knew that 5/10 was half, but we want 2/3, we know we have to go higher than 5. So let's try 6. Well, at 6/10, and the division here is easy, it's not tedious, we know that this comes out to 0.6. But 2/3, and I'm sorry, I should have said this before, 2/3, you want to go ahead and prep them with the decimal equivalent. So we're going to divide that out, and it's 0.66 repeating. So we need it to be a little bit bigger than 0.6. We can't use, it's not bigger than 2/3 if it stops at 0.6. So students are going to know then a little bit bigger means we have to go to 7/10. That decimal is going to give us 0.7, and we're going to be able to compare it, and yes, it's a little bit bigger than 2/3. Can use that same process for the rest. Notice that some of the fractions, they give them the top rather than the bottom. I love the way they switch their thinking on that. So what number, again, start with a half. What number would have to go here in order to make a half? Students probably are going to know that if you put an 8, and if they don't, show them. Go ahead and throw that 8 in there, and they'll go, oh, yeah, that's a half. So 4 out of 8 is a half, but we need it to be 2/3. So 2/3 is bigger than a half. So if I increase my bottom number, if I do 4/9, have I gotten bigger or smaller in my fraction? So students, now they have to think about that. Half of 9 is 4.5. So now we just got smaller than a half. That's not going to work. And if they need to see it again, go even bigger. 4/10. Are we bigger or smaller than a half? We're getting smaller as we make our denominator bigger. They're going to wrap their minds around that, and they're going to now take them back to the 8. Here's our 1/2. What do we need to do with our denominator? We need to go smaller. We need a 7 in there. Now students need to figure out, is 4/7 greater than a half? It is. But is it greater than 2/3? Now, you can do this 2 ways. You can have them divide it out on their own, which is great. Notice we don't need to go any further. We're going to get something that starts with a 0.5, right? That's too small. We have to be bigger than 0.66. So we're going to stop. We're not going to keep going. We're going to change this. Remember, we had to get smaller, so we're going to change it now to a 6. And if we change it to the 6, notice what happens here. This reduces. 4/6 becomes 2/3. Well, that's the number we're looking for, but they want it to be a little bit bigger, not equal to 2/3. So 2/3 doesn't work, so we can't use the 6 either. But now that we know that we were at 2/3, we know that if we go to 4/5, that we have a winner. Now, what I was saying before, that there's 2 ways to go about this. This is a great opportunity to hand those kids a calculator. There is no reason, if you're thinking about the math like this, there's no reason that you wouldn't give them a calculator to let them quickly find 4 divided by 5, or 7 divided by 10, or 9 divided by 12, to prove that they are correct and to move them along faster. If this is hard for them, you don't want them spending their time and energy getting frustrated with this. The lesson is about fractions and ordering and creating numbers that are close to 2/3. The calculator will help them, and they will like what they're doing a whole lot better. So that is student page A from lesson 1.